There we go. Okay. So symbolically, the way we'd write this out is if I had a number, I'm going to use a variable as a placeholder because this number could be any number. Let's say I had a number A. It could be 10. Let's just say that the number A is 10. If I add that to its additive inverse, well, the additive inverse is usually the opposite of that number, so it would be the negative version of that number. If I add those two together, I should be getting a result of 0. That should make intuitive sense because, for example, if I had $5 in my bank account and I added negative $5, right? Which is sort of weird to think about adding a negative, but let's say that I took on a $5 debt or a $5 charge. Well, if I had 5 in my bank and I add a $5 debt, those should cancel out. So how much money should I have in the bank?
0.
I should have 0, right? That makes sense to us because we all live in the world where we have money. Hopefully we're not getting into a place where we have a balance of 0 in our bank accounts, but it does happen sometimes, okay? Usually maybe if we buy a car or have a cell phone plan, you might have a negative balance until you pay off that phone or you pay off that car or that mortgage. But this works with anything. So if I had, let's say, negative 10,000 and I added its additive inverse or its opposite, the opposite of negative 10,000 would be positive 10,000. Okay, and if I added those together,
it will be 0, right?
Yeah, if I add those together, then the answer should be 0. Okay, this also works for fractions. If I have 1/2 and I add negative 1/2, then I should also get 0 here.
I have a question.
Sure.
What happens if there's a fraction problem saying 1/3 plus negative 1/2, something like that?
Did you run into that problem in the homework?
No, I'm just saying.
So if you have like 2 fractions that we're trying to subtract, then there's a process for doing that, but we're not going to get into fractions until next week. Okay, so I want to hold off. I want to hold off on that because we will add and subtract fractions. Right now, we're just worried about really whole numbers or integers. Okay, so we'll work with whole numbers. We'll work with whole numbers today, and we'll save fractions for a little bit later on. But I will circle back to that. Now, I will say 0 plus the opposite of 0, which is 0, is equal to 0. That should make sense. I'm just going to make a note here that 0 is its own.
Which one is going to be a negative 0?
There is no negative 0. So negative 0 is the same thing as 0. And so 0 is this special number that is its own additive inverse. That is its own opposite. Okay. So in some of these problems, we have to identify what is the additive inverse or what is the opposite of a number. In fact, that is a skill that we're going to need to do in subtraction over and over again. Be able to identify the opposite of some number that's given. So you will have some problems in the homework that say, find the additive inverse of a number. So if I give you a number, you have to tell me what the opposite is. So first, can anybody tell me what the opposite number or the additive inverse of 3 is?
-3?
Yeah, -3. Not a trick question, right? I'm just trying to get you to realize that we can just switch the sign and that will be the opposite or that will be the additive inverse, okay? If I ask you, what is the additive inverse of -7.3? Ooh, the cats are getting really feisty right now. Sorry about that. -7.3, what is its opposite?
Positive 7.3?
Yeah, positive 7.3. We don't have to put a plus sign in front of it to identify it as positive. We understand that if you just write a number and it doesn't have a sign, that automatically it's understood to be positive. What is the additive inverse of negative 9.2?
Negative 9.2.
The opposite of negative 9.2?
9.2.
Oh, sorry, it's positive.
Positive
Okay,
9.2.
positive 9.2.
Yeah, there we go. And just for good measure, what is the additive inverse of 0?
0.
Yeah. So that's the only number where it's its own additive inverse. Okay. So now that we can do that, we can identify what is the opposite of some given number. We can go back to our discussion of subtraction, but subtraction is related to addition. And I just want to do a little brief review of addition, right? Because when we added some numbers, we think of, when we add positive numbers, we think of that as piling up or accumulating some amount.
Sir, can I see that
of
page
money.
one more time?
Yeah, here you go. So when we're adding numbers, we tend to think as we're building up, we're saving up, that the numbers are getting larger.
I need the bottom page.
This is the bottom.
Well, I can't see the 0.
This 0?
Yeah.
Do I need to scoot it up or down?
Got it. Thank you.
Okay. All right, so when we're adding numbers, especially positive numbers, we think of that as adding up or piling up or moving us to the right on the number line. But that's only going to be true for adding positive values. So adding positive numbers, we can think of accumulating the numbers, accumulates in the positive direction. And in the positive direction, we're talking about in the right direction on the number line. Okay. That should make sense. Like if I have some problem like 5 plus 3, I can draw a number line where I have 5 and I need to move 3 units to the right. So the 1, 2, 3 would put me at this location, which would be 8, right? There we go. But adding numbers that are negative, you can think about it like we're taking away or subtracting, or you could think about adding negatives, accumulate in the negative direction. So the left on the number line. So if I were to add negative numbers, let's say that I started with -5 and I added.
So it's basically the same way how you had it in a positive way.
Yeah, so if I had -5 and I added -3, then I should go to the number line at -5, and negative numbers accumulate in the left direction. So I should go 1, 2, 3 in the left, and that should be -8. Okay, it gets a little bit trickier when we're adding a positive number and a negative number together. But fundamentally, this is what's happening. We're either shifting to the right or shifting to the left, depending on what is the value that we're adding, right? Where the sign here if this is positive, we're going to move to the right. If this is a negative number, we're going to move to the left. Okay. In subtraction, which is what we're focusing on today, we are looking for the difference or the distance between two numbers. Okay. So if I have a problem like 6 minus 4, we need to be able to interpret that on the number line. And we should probably know already that 6 minus 4 is 2. Is everybody okay with that?
Yes.
Okay. But the reason why it's 2 is because subtraction is finding the distance between those two numbers on the number line. And what we need to interpret these numbers as is the first number is the end point. The second number in subtraction is the starting point. And our answer here tells us not only the distance, but also the direction that we traveled. Okay. So if I were to draw a number line to represent this problem, then I would need to write 4 here. This would be 5. This would be 6. Okay. So what this problem is saying is that our endpoint is 6. That's where we ended up at. We started at 4. How did we get there? How many places did we have to move? So if we choose our starting point at 4, and we needed to get to 6, what direction did I move in? Did I move into the left or the right?
The right.
I moved to the right. And if we move to the right, then that means that our answer should be positive. And how many units to the right did I move?
3.
Did I move 3 units? Let's double check that, right? If we started at 4, we move 1, 2.
Oh, my bad, is 2. I'm sorry.
Yeah, we move 2 units to the right. So that makes sense. 6 minus 4 should be positive 2 because we're moving 2 units to the right. Does anybody have any questions about that?
I don't think so.
Okay. Does everybody write this down? Do we need some more time? Okay. I think we're good there. So let's look at another problem that's really similar, because I think that this one will be a little bit more confusing. So let's examine, how about 6 minus -4? Can anybody tell me what the answer to this subtraction problem, what should it be? Maybe take some guesses. Does anybody know what 6 minus -4 is?
-2.
I'm hearing -2. Any other guesses?
Would it be +2?
I'm hearing
Positive
positive
10.
+2. I'm hearing +10. Any other guesses?
No, it's definitely positive 10.
It's definitely positive 10.
Mhm.
Yeah, the answer is 10. Is that confusing to some people? Six minus -4 is positive 10. That is a true statement. And we have to understand why it's
How
true
is that?
so that we can figure out what is going on here. Okay. So what I'm going to do is draw a number line. Remember, subtraction is finding the distance between two numbers, where the first number is the end point, and subtraction is finding the distance between 6 and -4. So -4 is our starting point. Okay. So we can draw this on the number line. And I'll say, okay, 0 is here. I need to get to 6. So 1, 2, 3, 4, 5, 6. That's where 6 lives. And I need to start at -4. 1, 2, 3, 4. This is where -4 lives. What is the distance between these two numbers? Well, let's go ahead and count. If this is our starting point, then we need to start here and count how many spaces it takes for us to get to 6. How many units? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We move 10 units in what direction? Do we move to the right or
The
the
left.
is this the
The
left or the right?
I mean the right. I'm sorry.
To the right. And remember, 10 units to the right means that our answer should be positive 10. So the distance that we found is positive 10 units. So when we subtract 6 minus -4, that is finding the distance between those two numbers on the number line, and they are 10 units apart in the positive direction. Does that make a little bit more sense?
Yes.
Okay, let's look at another example. And with smaller numbers, it'll be manageable for us to go ahead and draw a number line just so that we get the intuition right. So let's say that I had -5 and I wanted to subtract, let's subtract 4. What should the answer to this be? Any ideas?
-9.
Does everybody else feel comfortable with -9?
I got -9.
Yeah, -9 is correct. Again, subtraction is finding the distance between two numbers. So -5 can be our ending point, +4, our starting point. So if we're looking at our number line, and I know 0 is here, I need to get to +4. That's where I'm starting. 1, 2, 3, 4. And I need to get to
This I need to be moving to the right.
3, 4, 5. That's -5. Well, remember, I'm starting here. And I need to move 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units to what direction?
To the right.
Are you sure that I moved to the right?
It should be to the left.
To the left.
Yeah, I moved to the left there.
Ugh, I'm getting my right and left backwards.
Okay, yeah, just be very careful there. So if I move to the left, well, that indicates to me that I should have a negative number as my answer. So that works out. Okay. But for larger numbers, you don't necessarily want to do this because, well, you don't want to draw a number line with a bunch of numbers on this. So for instance, let's say that I had, let's go with negative 25 minus, let's go with negative 15. Okay, can anybody tell me what the answer to this should be?
Negative 10.
Pretty sure that's right. Okay. But what I'm saying is, like, what we don't want to do necessarily is that these numbers are kind of big. They're both negative. So I would have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's negative 15. Negative 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's negative 25. And then find the distance between those, right? So I've already gotten sort of tired of writing these tick marks out. Okay. Well, my cats are getting really feisty, so give me one moment while I address them.
Can you flip over the page real quick?
Okay, sorry about that. I needed to separate them.
I got it.
Cool. What I'm saying is that when we start subtracting numbers that are much larger, like 25 or even 100 and something, we don't want to draw number lines over and over again because it's going to become too cumbersome. Already, I was tired of drawing all of those little tick marks on the number line. Then we would have to go, okay, this is the end point, this is the start point. So we'll start here, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units to the left. So we should get negative 10, right? So that works, but it just becomes cumbersome. It takes too much time that we don't have, right? So instead of doing that, what we can do instead is use a method called keep, change, change. And so what I'm saying is subtraction is addition of an opposite. Okay, what do I mean by that? What I mean is that if I have a number, let's call it A, and I subtract some other number B, then I can always just change that subtraction problem into an addition problem by writing this as A plus the opposite of whatever B was. So I'll put negative B since we had positive B here. That these two expressions mean the same thing and that they will give us the same answer. So that's what I mean by keep, change, change. That if we have a problem that's subtraction and it's sort of confusing to us, then we can just keep the first number the same, change to addition, and then change the second number to its opposite. Okay. And then we just have to worry about what are our rules for addition, right? When we're adding numbers with the same sign, we just add those numbers, keep the common sign. When we're adding numbers with two different signs, then we subtract the number, take the larger, subtract the smaller, and keep the sign of the larger number. Okay. So let's do some example problems using this keep, change, change method. Okay. So let's do one example here. Let's do like negative 143 minus negative 28. Okay. If I were to work this one out using keep, change, change, it's going to go a lot faster than if I were to draw a number line. because these two numbers are pretty far away from each other. Don't want to be drawing a number line. So what I'll do is keep this number the same. So negative 143. I'm going to change to addition. And then I will change negative 28 to its opposite. What is the opposite of negative 28?
28,
Positive.
positive 28.
Positive 28. Okay. And now I have an addition problem. Okay. I can forget about the original problem and I can just focus on this addition problem. This addition problem is adding with different signs. And as I alluded to before, if we're adding with different signs, what we really need to do is take the larger number, or the number that has a larger absolute value, 143, subtract the 28. We'll do that subtraction, so I need to borrow here. So this will be 3. This will be 13. 13 minus 8 is 5. 3 minus 2 is 1, and then I'll bring that 1 down. So my answer should be 115, but I need to keep the sign of the larger number. So I should have negative 115. So that is the answer when I have negative 143 and I subtract 28. Sorry, when I subtract negative 28. Does anybody have any questions there? Does that seem confusing? Okay, let's do some more example problems. Let's get a lot of practice in. We'll start easy. Negative 4 minus 1. What should the answer to this problem be?
Negative 5.
Negative 5. Is everybody okay with that? There's no confusion with that one? We're okay with negative 5? Okay.
I don't think so.
Okay, well, this should make sense. And we could think about it just to verify it for ourselves. We could do the keep change, right? We could keep negative 4, switch
I
to
have a
addition,
question.
and then just 1 second. We can switch this to negative 1, right? We'll do the keep change. Negative 4 plus negative 1, we're adding numbers with the same sign. Add, same sign. So we're just going to add the numbers and keep the common sign. So 4 plus 1 is 5. So we should keep that common sign of negative 5, and that makes sense. Okay, Brianna, what was your question?
So basically, this lesson is basically about graphing the negative and positive.
It's really just about understanding how subtraction works.
Okay.
Yeah. Let's do another example. Let's do negative 1 minus negative 8. Does anybody know what the value should be here?
Positive 7.
And can you tell me how you worked that one out?
Because the two negatives together in front of the 8 is turned into a positive. So negative 1 plus 7 plus 8 gives you positive 7.
Okay. Yeah. And that might be a rule that you remember from a previous math class, but it's essentially the same thing that I've been saying about keep, change, change, right? We can keep this number the same, -1, we'll change to addition, and then change to the opposite of -8, which is +8.
I got +7.
Yeah, it should be +7, right? Because now we're adding numbers with different signs. So -1 plus 8, we have to subtract that, right? We take the larger number, subtract the smaller number, we get 7, and keep the sign of the larger. So that's why this should stay positive. Okay. Good. Let's do 10.3 minus -2.3. What should this be?
This will be going on Canvas, correct?
Yeah, I'll go on Canvas later. Does anybody have an answer for this one?
Mm, 12.6.
Yeah. Did anybody else get something different? Should be 12.6. Okay. So again, we have this situation where we're subtracting a negative. And so if you wanted to, as just a shortcut or rule of thumb, you could say if I'm subtracting a negative, I'm really adding. But that's the same thing as applying this keep, change, change rule. We'll keep 10.3. We'll switch to the opposite. So we'll change to addition, and we'll change this one to the opposite. So this is 2.3. So now we're just adding numbers with the same sign. And this is same sign. Okay. So if we're just adding these up, we can just stack them.
Maybe the same problem, but same answer, but negative.
What do you mean by that? We should be ending up with a positive number here. So this would be 6. This should be 2. That should be 1 when we add that up.
Oh, okay.
And since they're both the same sign, they're both positive, then we should keep a positive here. So this is 12.6.
Some odd reason I thought when you swap it around, that problem would be a negative.
No. So when you keep, change, change, you just have to change the problem, keep this the same, change to addition, change the sign here, and then you're just worrying about your addition rules. If you have $10.30 and you add $2.30, well, you should have $12.60, right? Because they're both positive amounts. So you should stay positive because you're just accumulating money then.
Oh, okay, makes sense now.
Yeah. So let's do a few more of these. This is 4. 48 minus -32. What should this be?
$80.
Yeah, can you tell me how you did that?
You have to do the same change. So it would be negative 32 will turn into positive, and then you'll do 48 plus 32.
Yeah, perfect. So we're going to keep, change, change like we've been doing. There we go. There we go. And there we go. Now we're just adding numbers that have the same sign. Okay. So if we add these up, the 2 and the 8 make a 10. So that'll be 70 plus 10, which would be 80. Okay. What about negative 53? Sorry, negative 53 minus negative 20. What should this one be?
Mhm. Not that one.
What should we get as a result?
Negative 33.
Yeah, that's correct. Can you walk us through how you did that?
So you keep negative 53 and you change the subtraction to addition, and then you change negative 20 to positive 20.
And then where
And-
do you go from there?
And then that is adding with the different signs. So you
Correct.
subtract 20 from 53,
So 53 minus 20.
and then you get 33, and you keep the sign of the larger number.
Yeah, perfect. Perfectly explained. That's why we should get negative 33.
What? Oh, no, I don't like soccer. Sorry.
What's going on? Does anybody have any questions about that? Yeah, that's perfectly right. Okay, let's do another problem. Let's do negative 183 minus 45. And so if these are feeling like really simple to you, then good. You're starting with a good base foundation for how to subtract numbers. A lot of students that take Math 0410 struggle with this. But the class that I had right before this, the students, were confused at first, but then once they kept applying the keep, change, they were able to do these problems with more confidence. Okay, so we're going to throw a few more of these example problems at you guys. So what should I get here if I subtract these numbers?
I don't know.
Any guesses?
Negative 231.
Negative 231. Can you walk me through that process?
Because we're adding negatives, we're adding to a negative.
Yeah, so what do you want me to do here? Do you want me to rewrite it?
Dude, no, I don't want to freaking try it. Doesn't matter. Yeah, being and cheese? No.
What is going on? Okay.
I have a feeling that you're supposed to change. I mean, keep the negative 183, and then where it says where the minus is at,
Uh-huh.
I think it's you're changing it to a add
Yep.
instead of negative,
Perfect.
and then it's gonna be a positive 20. I mean 45.
Oh, no, be careful there. What is the opposite of 45?
Oh, negative.
Right, negative 45. Okay, so now we're adding numbers with the same sign.
Do I know the answer to it? No.
Okay, well, you have to remember that, in our discussion of addition, when we're adding numbers with the same sign, you just look at the numbers, forget about the sign. Add the numbers up, keep that common sign. So really, we're doing 183 plus 45. So we should get 8 there. That should be a 12 here, a 1 up, and then a 2 there. So I should be getting 228 as my answer, but because these are both negative, then I need to keep that common sign. Okay. Okay, so let's do another problem. I think we're on problem 7 now. Negative 253 minus 81. And actually, let me give you 2 more problems and I'll have you guys work them out. So negative 57 minus negative 120 and 52 minus negative 48. Okay. So take a moment to work those out. Let me scooch this down a little bit. I'll give you guys a few minutes to work that out. Then we'll jump in and explain them. But when you're done with them, you can go ahead and type in the chat that you're done, just so I know, I have an idea of how many people are done. Okay, are we still working on these? I have a few people that have typed in the chat that they're done with them. Is anybody still working on these? Cool. Yes, nice. Okay, I see that people are starting to type in the chat that they're done. Looks good. I'm gonna go ahead and run through them just so that we can, compare our answers, see if we got the same thing. So I'm gonna go ahead and do keep change here. So I'm gonna keep this as negative 253 plus, I'm gonna switch this to the opposite of negative 81. Then I know I'm adding numbers with the same sign, so I should be getting a larger negative number here. So what I'm really doing, let me go ahead and draw a little arrow here so I can stack these numbers. 253 plus 81 should give me 4, 13, bring the 1 up, 3. So this should be 334, but because these are both negative, I should be having a negative result. Is that what everybody got for the first one? Did anybody get something different? Okay, I'm gonna take that silence as a we're good. Continue. All right, so we'll go ahead and keep this negative 57. We'll switch to addition, switch this to the opposite, which is going to be 120. And I threw parentheses around here just because I accidentally wrote it. Don't need the parentheses there. But now I'm adding numbers that have different signs. So when I have different signs, I need to take the larger number, subtract the smaller one. So let me borrow here. So this will be 1, this will be 10, get a 3, need to borrow again. So I get 63, but I need to keep the sign of the larger one. So this remains positive. Okay. Any questions on that one? Okay. Then when you straight up just have like a positive number and you subtract a negative, one quick trick that you can use is if we have negative negative, that we could just sort of connect them and it looks like a plus sign. But that's the same thing as doing keep change change. So 52 stays the same, switch to addition, switch this to its opposite, which would be 48. Now we have numbers with the same sign, so I can stack this up, 52 plus 48, and I should get a 10 there, 1 up, and another 10 there. So I should have a positive 100, since positive is the common sign.
Sorry, sir. Where is this 253? Is right next to it? Is it a positive or negative? Where you did 253 on the side of the, yeah,
Or
on
over
the
here.
side where the equal sign is at, the arrow.
The arrow is just saying take the numbers and add them. So I just
Yeah,
took
I know, but did you put negative or positive?
No, this is a positive,
Okay.
right? I'm just dealing with the positive or the absolute values of the numbers.
Okay, I wasn't too sure.
Yeah. No, and this 1 here is just because I carried a 1 when I did the addition. Okay. Does anybody have any questions about these? Does that feel pretty straightforward? Okay. Well, in your homework, you're going to run into some word problems as well. So bear with me as I walk you through a couple of these word problems. These word problems are associated with something called change in value. And so what we need to be able to do is read the word problem and then understand how to set up the problem as it's described. So to find the change in value between two numbers, I'm going to give you a formula that we will use to guide us in solving these word problems. The change in value is equal to the end value, so that is the value that we end with, minus the beginning value. So this should be related to how we first started our discussion of subtraction today, right? The first number that's listed in subtraction is that end point or the end value. The second number that's listed in that subtraction problem is the beginning value or the start point, okay? So let me give you a scenario. Here is an example. And bear with me because it's a lot to write. At noon on Tuesday, the temperature was 34 degrees Fahrenheit. Okay, that's the end of that sentence. By noon on Thursday, the temperature had changed to -5 degrees Fahrenheit. How much did the temperature change? Between Tuesday and Thursday. Okay. So take a moment to write that down. I'm going to take a strategic sip of water. And let's think about how we could go about setting up this problem to solve it. Okay. At noon on Tuesday, the temperature was 34 degrees Fahrenheit. By noon on Thursday, the temperature had changed to -5 degrees Fahrenheit. How much did the temperature change between Tuesday and Thursday? That's the question we're trying to answer. So how could I set this up using a subtraction problem so that I can find the answer to this question? How would I write this down?
So since it changed to -5, that would go into the end value.
Right, so the end value comes first, and that's going to be -5. Then what?
Then you will subtract it by the beginning value, which is 34.
Yeah, perfect. So that's the beginning value. So that is how we have to set it up. You have to be very careful with this. You know, I had students in my last class say, take 34 and subtract 5. But, you know, the question as it's laid out says the end value comes first, then subtract the beginning value. At the end of the week, on Thursday, the temperature was -5. So that's how we know that that is the end value, because it's the end of the week. On Tuesday, the temperature was 34 degrees. That's how we know that's the beginning, because Tuesday relative to Thursday is the beginning of the week.
Okay, so for us to solve the equation, is it for us to bring down the 5, the +5? Because it's going to be the same.
No, so what we need to do here is go ahead and set this up correctly, right? Get the end value first, subtract the beginning value, and then just work that subtraction problem, okay? So if I needed to subtract these numbers, how do I do that? What is the process that we've been using so far?
So you're basically telling me that we had to solve the problem just like that?
Yeah. Like once you have it set up correctly, then we just need to solve this problem. What is -5 minus 34? Well, the process we've been using this entire time is to keep change, right? So this should be -5. We're going to keep that. Change to addition. And then take our second number and switch it to its opposite, which is -34. So if I then am adding these two negative numbers together, what should my result be?
-39.
Yeah, -39. There we go. Sorry, I wrote that a little bit weird, but -39 is correct. And that should make sense because our end value, if we think about a thermometer, and so let me just draw sort of a thermometer, usually they're vertical. The thermometer down here is saying we're at -5 degrees Fahrenheit. That is our end point. But we started off at 34 degrees Fahrenheit. So to go from our starting point to our ending point, what direction did we go? Well, if we're thinking about a thermometer, then the temperature fell or dropped to -5 degrees. And if that temperature dropped, that is a distance of 39 units. But since we dropped, our value should be negative, right? So that should make sense. Okay, now let me give you one more word problem just so that we have a good sense of what to expect in the homework. So here's another example word problem. A jet pilot flew her plane from an altitude of 30,000 feet to an altitude of 12,000 feet. What was the change in altitude? Okay. So how do I set this one up? How will I write this one down as a math problem?
Would it be 12,000 feet minus 30,000 feet?
Let's see. We flew from an altitude of this to that. So our ending value should come first, right? So let me just write that down. End value minus beginning value. And that's going to guide me, right? The end value, yeah, is 12,000 feet. And I'm going to subtract the 30,000, right? Okay. So what should my answer here be? Well, one intuition that you might use is like, forget about altitude altogether. Imagine that we're talking about money. If I have $12,000 to spend on some sort of like home improvement project, but then I subtract and actually end up spending 30,000. Well, I've gone over budget. So I've spent more money than I intended to. So I owe somebody some money, right? That means that I know my answer should be negative because I had less money than what I ended up spending. So we have that intuition that our answer should be negative, but let's go ahead and use keep change. So we'll keep this as 12,000. We'll change to addition, change to -30,000. And that might seem like it's more confusing than it needed to be. Maybe you could have found the answer some other way. But okay, let's just stick with the process. Now we're adding numbers that have different signs. So if we're doing that, we need to remember to take the number that has the larger absolute value and subtract the one that has a smaller absolute value. Okay, so we should get 0, 0, 0. We're going to have to borrow here, get a 10. That'll be an 8. This will be 2 minus 1, which is 1. So our answer should be 18,000. But we need to keep the sign of the larger number here, which is negative. So we have a drop in altitude of 18,000 feet. That is, our change in altitude is negative 18,000. Does that make sense, or does anybody have any questions about that? There we go. So just be careful that you're not accidentally hitting the unmute button if you're doing something and playing some music in the background. But in any case, that is all that we needed to get through today. We're just doing subtraction. So that takes us through all the homework that I posted in Hawks. One note that I have to make before you guys leave is that you should have gotten an email or a message to your phone saying from the Alamo colleges that we're extending the remote or the Zoom classes for an additional week. So next week, we are going to meet via Zoom again. So just be aware, we are not meeting on campus next week.
Yeah, I got somebody told me that we won't return to campus on my birthday, which is February 7th.
Okay. If that's the Monday, then I don't know if that's the correct date. It's either February 6th or the 7th, whichever is the Monday. But that is the plan for now. They've extended us to be remote for an additional week. So just keep in mind.
I'm kind of confused because one teacher of mine told me on the 6th, and another teacher of mine also said February 7th, which is my birthday.
Let me go ahead and take a look at the calendar real quick. It's whatever that Monday is. So that Monday is the 7th. So we will return to campus on Monday, February 7th. So next week, I will have in Canvas some Zoom links so that you can get into the Zoom session again. All right. So I'll send out a reminder and an announcement in Canvas just so that we're clear for anybody who missed. Next week, we're going to be doing this via Zoom again. Okay. But if you have any homework questions, any questions of any problems that are giving you some challenges.
Isn't there 4 homework assignments?
There are 4 homework assignments. It goes through this section on subtraction. So those are due Sunday. Just remember to get those done. I will send out a reminder announcement in Canvas. But if you have any questions, hop into Math World, get some one-on-one tutoring help with them. They are via Zoom. Remember that you can see their hours and see what tutors are available. And if that doesn't work out for you, send me a message and I'll do my best to get back to you. If you see any sort of weird changes going on in Canvas, just know that I'm working in the background to make updates and modifications to Canvas. So don't worry about it too much. Just make sure that you get those homework assignments done, okay?
If you have one question.
Okay.
How can I find a one-on-one tutoring for a different class?
That is a good question. You'll have to contact the TNT Center. I can send you that information a little bit later on.
That'd be nice.
Okay, I'll send you that information later. So
Okay.
For anybody else, if you have any other questions, you're more than welcome to stay behind and chat, but otherwise you guys are free to go.